Okay, so welcome back to another video on this GCSE 5-day series. I'm so sorry I didn't post a video yesterday, but because you know how lazy I am. So this is 13th Jan, and we are doing the grade 6, grade 7 questions of the day. Right, so the first one is find the area of a sector. So if you want to find the area of a sector, the technique is, well, we all know how to find the area of a full circle. So if you imagine this to be a full circle, the area of that full circle would have been pi r squared. And so pi r squared, my radius here is 4. So that would be pi times 4 squared. But if you think about it, I do not have a full circle here. I only have a part of the circle, or I have only a fraction of the circle. Then the question is, what fraction of the circle do I have? Well, if you think about it, I've got the full circle is worth 360 degrees, and I've got 29 out of the 360 degrees. That means I've got 29 out of 360 as a fraction of the circle. So that means the area of this piece, or the area of this fraction of the circle, or this sector, this slice, would be 29 over 360 of the pi r squared. So I could say this is 29 over 360 of pi r squared, and if I plug that onto my calculator, so that would be 29 over 360 times pi r squared, so that's pi times 16, and the answer on my calculator is, if they say give in terms of pi, I would write 58 over 45 pi, or if you're doing it as a decimal, you could give your answer to 3 significant figures as 4.05. So when you're doing a sector question, remember, ask yourself what fraction of the circle is it, and then if you can find that fraction, that's it, you can figure out your area. Next question, work out the area of a triangle. Now, if you want to work out the area of a triangle, remember there are two formulas that we use. One is our year 7 formula, half base times height. Then we have our GCSE formula, which is half a times b times sine of the angle C. Now, when you're using this formula, all you need to ask yourself is, if you have to use the second version, the trigonometric version, ask yourself, do I know a trapped angle? So this C has to be the trapped angle or the sandwiched angle. So here you do have the 140, which is being sandwiched by the 19 and the 15. So that would be half times, it's the sandwich sides, which is 19 times 15, times sine of the angle 140. The most common mistake that I've seen people make is they tend to write cos instead of sine for some reason. So please don't get mixed up with the formulas. It's half, and remember these two sides are the sandwiching side. So let's say if they gave you a 20 here, I wouldn't actually use the 20. I need only the sandwiching sides. So that's half. So let me plot that on the calculator. So that's half times 19 times 15 times sine of the angle 140. But when you're doing this, you need to make sure your calculator is in the degree mode, minus naught. So let me quickly change that. So I need to be in degrees. So 0.5 times 19 times 15 times sine of the angle 140. So that would be 91.59. So 3 significant figures, that would be 91.6 centimeter squares. So even this one is centimeter squares. Next one, we've got a car that travels at 50 miles an hour to the nearest 10 miles per hour. So whenever I hear this, I know we're talking about error interval. So let's first write that. So I know it's 50 miles per hour, but it's to the nearest 10. So I've got 60 to the extreme right and then 40 to the extreme left, which means my error intervals are midway of these. So that would be 45 less than or equal to speed less than the upper bound, which is 55. It travels 220 miles to the nearest 10 miles. So the distance is 220 to the nearest 10. So that's 230. This would be 210. But the error intervals are not the extremes, they are halfway of those. So that's 205 less than or equal to the distance less than, this would be 225. Okay, what is the shortest possible time? So to figure out the shortest possible time, first let's look at the formula for speed, distance, time. So it's S, D, and T. So I know time is equal to distance over speed. Now, if I want the shortest possible time, so I want time to be small. So ask yourself, when you're dividing money amongst your friends, you get very small amount or very small money per person if there is a less money that is being split among a more group of people. So if there are only £10 and it is being split among 5 people, each person would get only £2. But if there's only £10 and if it is being split among 2 people, each person would get £5 each. So if you want less number in your answer, and if it's a division question, your numerator should be smaller and your denominator should be bigger. So I'm going to choose the smaller value for the distance, which is 205, and I'm going to choose the bigger value for speed. So that's going to be 55. So if we do 205 over 55, that should be 41 over 11. So the time is equal to 41 over 11. And that's in hours, but we would like that in hours. So that's 3.72 hours. So that's our shortest possible time. So remember that idea. If you want a small per head per person when you're splitting money among friends, if there is less money and you're splitting it among a more number of friends, each person would get only a few pounds. But if you want it the other way around, if you want more in your answer, or if you want a high per head, then that means you should have a large sum of money to be split among a small group of people. So in that case, your numerator should be bigger and your denominator should be smaller. Okay, let's look at the next one. Helen is taking part in a quiz. The probability that she answers correctly is 4 over 5. So probability of getting a question correct is 4 over 5, which means getting something wrong would be 1 over 5, because it's only 2 ways. Either you get it right or you not. So it's either 4 over 5 or it's 1 over 5. Helen is asked 3 questions. Calculate the probability that she answers all the 3 questions correctly. So if we try to think of this as a probability tree, you want correct, let's say this is incorrect, but you want all the 3 to be correct, right? So we're not interested in any of the other branches that we get from the tree. We are only interested in this one, which is the correct. So Getting correct the first time, that's 4/5. Getting correct the second time, that's also 4/5. Getting correct the third time, that's also 4/5. So the only branch, so you don't have to draw the tree diagram for everything once you realize that the only branch that you need is the correct one. So that would be, as you move along the probability tree, you pick up those numbers that you collect and then you times them together. So that would be 4/5 times 4/5 times 4/5, and that would be 64/125. So 3 questions, getting 3 out of them right is 64/125. This one looks a bit interesting. Let's see, an oil tank loses 32% of its contents every hour. Theo says the tank will have lost 95% of its original contents by the end of the 6th hour. Is Theo correct? Okay, so it's an interesting one. So let's see. So if I start with, let's say, 100, so I'm going to assume I start with 100 liters at the beginning. So we say after 1 hour, we would have lost 32%. Now, one way of doing this is when you think you are losing, our natural tendency would be we are losing 32%. So we might think we should do subtract 32. And yes, that is right in a sense. And we would end up with 68%. Okay. It works only for the first hour, because from the second hour, you cannot do subtract 32% because you don't have the 100% anymore. It was for the 100% that you're using the 32. You can't use the 32 on a 68. So what we should have done, or what's technically, so whenever you're doing increase or decrease with percentages, if you remember year 7s, we tend to do, or the better way of doing this is, we are losing 32%, which means we should be timesing this by 0.68. Where did I get that from? Well, I know that it is each time I am losing 32%. So if I have 100%, I am losing 32%, which means each time, or as every hour passes by, whatever is the quantity that I have, I now have only 68% of whatever is remaining with me. I hope that makes sense. So I had 100% with me. Now I have only 68% of the 100. So let's say I had 100 liters. Let me change the percentage there. I had 100 liters. Now I have only 68% of that, which is 68 liters. Again, I would do times 0.68. I could do this for the third hour. That's times 0.68. Do that again, do that again, do that again. Or the quicker way I could do this is, I need to know at the end of the 6th hour. So that means I have to do 100 times 0.68 to the power of 6, because we're thinking of 6 hours, right? Now, what I want you to notice here is, let's say if I had done 68 times 0.68, I would have got 46.24. So each time my liters are coming down by 68, or coming down by 32%. So if I instead of doing that timesing by 0.68 every single time, I could just do 100 times 0.68 to the power of 6. So I could do that to the power of 6. And if I do that on my calculator, we would get 9.88 liters remaining. So, well, that's like saying I started with 100 liters. Now I have 9.8 left. So how much liters have I lost? I have lost, how much is that? That's 81. No, that's 80-ish, isn't it? 100 take away 9.88 would be, oh, that's not, yeah, that's 90.12. So I have lost 90.12 liters. So have I lost 95% of it? Because I started with 100. I have lost 90.12. So because it's 100 and I have lost 90.12, that's approximately 90%. So it's not 95%. So Theo is incorrect, as we have lost only 90.12%, and it is not 95%. So the technique here is whenever you're doing percentages with repetitive increase or decrease, even sometimes we get that in population as well. So if you are increasing population or decreasing depreciation, so we're doing 0.68. So each time it's becoming 68% of the previous amount. That's why we're multiplying by 0.68. Another way of asking this question is, let's say we could do this as if it was a population increase. So let's say I had 2,000 people in a town somewhere, and its population grew by 15% every year. So if I want to calculate the population at the end of 3 years, so at the end of the first year, this has grown by 15%, which means I'm going to do 1 plus. It's not one takeaway. One takeaway was for that's how I got the 0.68, because we did 1 minus 0.32, losing 32%. This time I'm increasing, so it will be 1 plus 0.15, because my population is increasing. And I'm not adding 15%, I would be timesing this. So we get 2,000 times 1.15, and that's the end of the first year. If I want to do this for 3 years, all I have to do is just multiply that by 3, and if I do that, I would get 2,000 times 1.15, and then that is to the power of 3, and that would be 3,041.75, but because it is people, you could round. That's approximately 3,042 people. Okay, so if it is a percentage, if it's something is increasing, you would do 1 plus that percentage. Remember, it's always multiplication to increase something by a percentage. And if you're losing, then that will be 1 minus that 32%, and then you're doing repeated multiplication. So that's the end of the 5 questions for today, and I'll see you again in another video.